Hi, I'm Gordon, and this is the third video in a series where we're putting together an aspect-based sentiment analysis. And we started off pre-training a BERT model, and we used the IMDb dataset from Stanford for that. And I went through that process 3 times and changed up the training each time, and ended up with 3 different BERT classifiers. And I asked them at the sentence level to predict whether each sentence contained in my corpus, which again, we're working with NHL scouting reports here. I asked these classifiers to determine whether these were positive or negative sentiments contained in each sentence. And in the last video, we put together all 3 predictions, and we've got a data frame here that represents the predictions for these. So these, as a reminder, these 3s mean that all classifiers agree it's a positive sentiment. -3 means that they all agree it's a negative sentiment. -1 and +1 represent that, one of the 3 models disagreed with the other 2. And then where you're seeing these zeros here, these are filler, which I plugged in, because remember, these scouting reports, not all of them are the same length, meaning, for our data frame, for the purposes of keeping our data frame, we're going to have to fill in some values. So that's what these zeros are. They are representative of, a lack of sentences in that report. Now we also, you'll remember, filled in our own, a sentence of our own making, and that's what this is. Anywhere where there were missing sentences, just for the sake of keeping a nice, neat data frame, okay? And what we're going to be doing in this video, we're going to be going into the topic modeling side of this project. So with aspect-based sentiment analysis, you need to be able to predict whether the sentiment is positive or negative, first and foremost, but then you also need to be able to get an insight as to what it's about. Is the sentence talking about, for our purposes, it might be physicality or skating or a player's offensive ability or their skill level, who knows. We're going to create this topic modeling algorithm, and we're going to ask it to tell us what are the topics, what are the things that get talked about in this corpus of scouting reports. Okay. So in order to do this, I'm moving all sentences here into a single column object called stacked. It's just what I've chosen to call it. And this, you'll see, we're going to iterate through this. We've got about 43,000 sentences. And now let's get into the topic modeling here, and I will point out an important YouTube page here, because I want to give credit where credit is due. Okay, here we go. So this is the page for Alice Zhao, and she's got a lot on natural language processing. The code that I'm using for this LDA algorithm comes directly from her page, and specifically this video that I'm hovering over here. I highly recommend that you go check it out. So again, credit where credit's due. The creation of the LDA algorithm and our text cleaning and preparation for using that algorithm all comes from her. So here we're taking out the things we don't want, the characters that we don't want. I'm not going to spend a lot of time on this because, again, it is her code, and I encourage you to check out her video. We're saying we only want the nouns or the adjectives, and that does prove to be a very useful tactic when we're working with this particular algorithm. Then we're going to apply the function we just created. Okay. And down here, we're taking out stop words and words that I've, through experimentation, found show up often in the corpus and sort of confuse the issue. We're creating a document term matrix. We are creating the Jensen corpus. If you're not familiar with what these are, encourage you to research this on your own, or again, check out Alice's videos. We're creating a vocabulary dictionary, which is going to be very important here for two reasons. One, it's necessary for this algorithm, but also we're going to use it as a springboard for a certain portion of this project, which I'll get into in a second. And I'm just showing you what this looks like. It is just a dictionary, right? And we've got these words and these identifying numbers for them, which are going to be important later on. So down here, once we've created all the things that we need, we are calling for the LDA model. And by the way, there are certainly imports you need for this. You know, almost everything you see here, not, you know, some of these are not necessary, but certainly for this particular video, anything in LTK, obviously pandas and NumPy, all of these GenSim imports are necessary. Yeah, okay. Let's get back down here. We're calling this, we're saying go ahead and create, you know, iterate over our corpus and create for us what you think, model for us what you think that the topics are. Okay. Now there are a few ways that we could improve this, but we're going with the, this is our first pass attempt, right? So we're going to do this quick, and then, you know, maybe later we do it right. But for right now, I just want to get through this. The topics, we can take a look at what are the top words per topic using this print topics function. And, you know, what do we see here? Well, we see, you know, this first line up here. This is the first topic, second topic, and so on. And some of these seem to really make sense, right? Look at number 2, for instance, right here. We see speed, skater, stride, skating, rush. Obviously, this word is about skate, or this topic is about skating. These words all fit together really well. We also have some that are a little bit harder to really see, you know, what's the underlying topic. This one, for instance, defensive game. Okay, so we're talking about defensive game, but then there's also size, and I don't really know how areas fits in. Opponents. This is the word that we use to replace offensive, remember. It's difficult to say exactly what's going on here. But I would suggest, just looking at it, that there's actually a lot in common between topic 1 and topic 3, where we're seeing, you know, physical and game, you know, the combination of words physical game shows up a lot in these scouting reports, I can say, after having read all of them at some point. Solid two-way frame. So this seems to be talking about physicality, especially, you know, when you get into talking about the physical frame of a player. And then up here we've got, you know, size, that kind of thing. A lot of these, it is difficult to say what the common thread actually is. Accurate teammates, age, awareness options. And this is just one run through of this algorithm. I'm not going to run it again right now because it actually does take probably about 12 minutes or so to run this and get a new set of topics. But there are tweaks that can be made to this that could probably make it a little bit better. Down here, this is an important thing. We see our filler sentence, all of the words from our filler sentence showing up together in being contained in a single topic. That's exactly what we want. All right. I like what I'm seeing down here with skill level and shot both showing up. But then we also see, you know, strength, hard, and strong showing up in that same topic, so that could be a little bit confusing. All in all, there are some things to be excited about, such as this one, and there are some that I see here that I think are not very tight representations of topics. Okay, now I'm going to stop this video before it goes on too long, because in the next one we're going to get into some more intense code. But before I stop here, I want to specifically call out the fact that we're doing something a little bit fringy. We're doing something that's a little bit outside the norm for this algorithm, and that is applying it at the sentence level. The LDA algorithm attempts to model what the probability distribution is for certain words showing up within certain topics. And in order for that to work properly, or in order for it to work at its best, it really prefers to have large documents, such as news articles. And here we're saying, no, we're going to shrink it down to the sentence level, which might just be a few words, you know. If we think about what that does, it's maybe a little bit hard sometimes to think abstractly on this level, but if you try to think about what that does for an algorithm that is attempting to model the likelihood that certain words show up in certain topics, it's easy to see how it's going to get confused, and it's going to have a hard time really drilling down to what's there. Anyway, I'm going to pick this up in the next video, and we'll go through some code, and then I will, at some point here, talk to you a little bit about why this seems to work much better on this corpus than it would on more traditional corpora, such as collections of news articles, movie reviews, even collections of tweets, so on and so forth. All right, thanks so much for listening. We'll pick up in the next video.